Okay, we can start. We you see my screen? Yes.
Yes.
Yeah. This is a sketch of a closed circuit wind tunnel with open test section. There are two basic type of wind tunnel with closed circuit like this and with open circuit like this. This open circuit, so inlet and outlet open to room into room, and in closed circuit wind tunnel there are no inlet and outlet, and air flow constantly by this loop. In both type of low speed wind tunnel we have a engine with propeller that moves air through wind tunnel, this, and in this type this. Sometimes we have a two contra-rotating propeller for better efficiency. Also, this we have open test section, and in this case we have closed test section. For example, this is a closed circuit wind tunnel with closed test section. So we have four basic options. Test section will be open and closed, and overall circuit of wind tunnel will be closed or open. Open circuit wind tunnel are cheap in construction, but something expensive in exploitation, because when you work with tunnel every day during week, during years, the most important factor of price is efficiency and electricity. Every wind tunnel driven by electric motors, and wind tunnel consume electricity like a small city. For example, in Antonov wind tunnel, we have electric motor from submarine, old Soviet submarine. After the commission, they put electric motors in wind tunnel. 5 megawatts maybe of power. In so closed section wind tunnel have a better efficiency because you don't waste your air in surrounding. You have 4 corner in wind tunnels when airflow rotated by 90 degrees, and in corner you have installed guide vanes, this airfoil like shapes, this and this and this help air move smoothly through corner. When you have no these vines, in that case we have separation, we have vortex, and quality of airflow in wind tunnel very bad. So everybody needs to install these guidelines. In these books we have detailed description of these guidelines, and 10 pages down, maybe more, and they, for example, this picture also have these guidelines. These books describe also construction and design of wind tunnels, calculation, and also these airfoils. I just need to find exactly that page. Objective, quality of airflow, power of wind tunnel, and there are also for this guidelines. But mostly, oh yes, turning vanes profiles. They describe profiles, they describe what mean eta, corner loss coefficients. And these guidelines designed to minimize this corner loss. Mostly these guidelines very similar to engine, jet engine, compressor and turbine, and this airfoil design of airfoil of these guidelines very similar procedure for turbine machinery. I seen this information in these books, but I know I cannot find exactly that page. This page about design of fan for wind tunnels. Oh, return for our topic. I need to discuss other component of wind tunnels. So corner guidelines for prevent corner loss and for improve air quality at corner. And next part of wind tunnel is a honeycomb. This like a bee honey, yes, a lot of hexagons, and the size of these hexagons selected to break down a small vortex. So the honeycomb reduce turbulence level in wind tunnel. There are also recommendations for sizing of honeycombs, and this depend of flow speed, depend on turbulence level. After honeycombs, they put screens. In these pictures, we have no screens, but I want to show you screens. Screens like a mesh from wire, rectangular mesh of wire with different diameters of wire and different cell size. And after honeycomb in flow direction, so flow direction this flow from left to right. And after honeycomb, they put 3, 5, or 0 screens. This also depend of desired turbulence level. When you need a small turbulence, when you need a laminar flow wind tunnel, you put a lot screens after honeycomb to break down vortex. Small, small, and small scale. Sometimes cells between wires size at 5 millimeters, maybe 1 millimeters. And after honeycomb and screens, we have contraction sections. And the very important parameter, contraction size. This is a ratio of area between this part inlet and this part outlet. And this ratio of area give us a ratio of speed. Also in contraction sections, in these sections, larger vortex become a small one because when you contraction area, the size of vortex also scale down. And in low turbulence wind tunnel, we have a very high contraction ratio, like a 10:1. In high turbulence wind tunnel, we have a moderate contraction ratio, maybe 3:1, 4:1. But every wind tunnel has these contraction sections. So with this wind tunnel, this is contraction sections. With this design, also we have these contraction sections. And this design discussed in these books also show us same contraction sections. This is basic equation, and from page maybe 25, they start design description of design wind tunnel. Yeah, second chapter exactly about our topic. Yes, open circuit wind tunnel also have these contraction sections and have screens in inlet. After contraction sections, we have test sections. In test sections, we put our models of aircraft. And in open test sections, we have a very simple access for people, for equipments. We have no limitation of size, and we very fast in changing of model from, or sometimes model need to adjust maybe flaps, for example. If your aircraft have flaps and we need to test aerodynamics with different flaps angle, you just stop wind tunnel, man go into test sections with driver change angle of flaps. Sometimes new design of model for aerodynamic experiments, they have a servo inside, like airplane model, pre-flight model, radio controller. Sometimes they use it such servo inside the wind tunnel model, but there are some limitations. For example, moment that act on flaps sometimes very high, and the servo cannot work with these loads and break down. And sometimes it's just fixed by a screw. And we need to stop your wind tunnel to change angle of installation flaps, ailerons, rudder, chassis of aircraft, landing gears put at your model or screen. So you have a lot of work inside test sections between a run of wind tunnel. And if you have open test sections, is a simplification of work. In closed test sections, you need to open door, maybe extract model from wind tunnel, and this is a lot of time. With open test sections, is very simple, but open test sections very influenced by environments. So when you have change of temperature in building, like something opens the window during experiments, so change it air temperature, pressure, maybe acoustic fluctuation, and this is effect on test results. In closed text sections, there is no environment issue. So with closed text section, we obtain better results in quality. But with open, we have a time saving. So it's a matter of selection. When you design wind tunnel, you have to select what type of test sections you put in your design. After this part, they called nozzle in tunnel with open test sections, and this also inlet. And after inlet, you have opening in contour, the slot, and this slot designed for, there are additional pulsation in airflow, and this slot dampen this pulsation and improve quality of flow. There is no such slots in closed circuit wind tunnels. Oh, this closed test chamber test section, but in tunnels with open test section, these slots are necessary. After we have diffuser. Diffuser have a small ratio, airflow expanding in diffuser, so speed down, and this is for better efficiency of propulsor, for propeller. So in contraction sections, we have increasing speed to desired level, and in diffuser we have decreasing of speed, so speed increase in this part and decrease in this part. After propeller, you just have return channel to inlet. For example, in Antonov facility, this wind tunnel, this driving of wind tunnel very similar to that one we have in Antonov. And this is a three floor of building. This is a cellar level, this is a first floor level, and test section, and all this machinery, test equipment at second floor of building. So this is a vertical oriented design. In this picture, we have horizontal located design, all part of wind tunnel and one floor of building. Also, this also very similar to our Antonov wind tunnel, also closed circuit, but with closed test section. Also, this we have a lot of screens. We have no screens in Antonov wind tunnel. We have only honeycomb. But in this, maybe something American Defense Establishment Research Agency, we have 5 screens. So this is a very, and high contraction ratio. This is a very low turbulence level wind tunnel. So after book discussed advantage and disadvantage open or closed test sections, but we need to talk about something different. Wind tunnel for vertical flight, like you need to test helicopter or VTOL aircraft. There are some different requirements. In VTOL aircraft, we have a larger downwash angles. You helicopter or your VTOL fighter, like a Harrier, put a lot of air in downward, in down direction. So, and so VTOL aircraft in transitional flight mode run with a small speed. So the wind tunnel for VTOL application need a slow speed in test sections, but need a very large, very big dimension of these test sections. And this is an example of Lockheed Martin wind tunnel, and they have 2 test sections. Big one for VTOL application and small one for conventional application. They have 30 feet of high and 24 wide test section for VTOL, and very wide and limited altitude, half of this altitude, 30 and 16 feet height test sections, and they have additional contraction cone. They have first contraction cone, they increase speed, and after V-stall test section, they have second contraction cone. And they have 3 diffuser, these expanding sections, diffusers that need for slow down airflow, and they have 3, first, second, and third. They cannot do experiment with both test sections in some time. They put model only in first or in second, depend on work scheduler. Next. Also, we have sometimes wind tunnel for V-stall application with single but high dimensional, high size test sections and slow contraction ratio. Low contraction ratio. So on. Another very important kind of wind tunnel. This is a wind tunnel for spin. This is a vertical oriented wind tunnel. There are flow run in vertical direction, and they put free flight model in this wind tunnel. And this is for analyze spin of model, spin recoveries, rudder, elevator, and so on. What exactly setting of this control surface help pilot to recovery aircraft from spin. And when you design aircraft for civil application like airliner, or when you design aerobatic aircraft, like when you design fighter, you need to test spin characteristics of your aircraft at very large side slip and attack angle of attack. There are also a picture of vertical aerodynamic wind tunnel in this book. We have 2 different designs, but they all have vertical oriented flight flow. In this picture, we have open circuit wind tunnel. This is an inlet. In this, we have screens. We have mesh from wire, and this mesh, like screens in wind tunnel, break down turbulence vortex and give high quality airflow at inlet. And this building have this first floor as inlet for wind tunnel. After contraction sections, the flow change direction from horizontal to vertical and go in test sections. Test sections from 3rd, 4th, 5th floor of this building with all test sections. And after test sections, we have propeller, fan that drive air, that suck air from all this building, and exhaust nozzle at topmost point of this building. This is a open circuit wind tunnel for spin application. And this sketch shows us closed circuit wind tunnel, but vertical oriented. It have all components discussed previously. They also have 4 corner, 4 sets of guide vines. They have propeller, they have diffuser, it have contraction cone, open test sections, free flight model that spin in this vertical flow, and you can do all experiments that you need in vertical flow of this spin wind tunnel. Also, this spin wind tunnel can be used not for aircraft experiments. This can be used, like, for example, for entertainment purpose or parachute jumpers need to adjust position during free fall, and sometimes vertical oriented wind tunnel used in entertainment center, like just for fun. When you obtain airspeed like maybe circa 50, 55 meters per second, so this enough for lift up a man, and people can lift in this flow, hover in this flow with different body position, and it's very fun. And a lot of vertical wind tunnel used in entertainment. There are no requirements for air quality in this case. Turbulence level, no matter when you just use it your wind tunnel for parachute jumpers. We have no vertical wind tunnel in Ukraine, but this kind of wind tunnel are in Moscow. 105 T-105 wind tunnel in Tsahi, Zhukovsky, near Moscow. And Antonov aircraft was tested in this wind tunnel for spin condition. We produced model, we wrote program of experiment, and the experiment was conducted in Moscow facility. After this book describes wind tunnel for automotive application, when you put your car in wind tunnel, there are a lot other requirements. In aircraft, there is no surrounding, but in car simulation, you need to simulate road cover, and you need to simulate moving road cover, because reversibility principle don't work for body near to flat surface. And when you have a takeoff aircraft or you have car in wind tunnel, you need also to simulate moving surface beneath of your aircraft or car. And in automotive applications, there is no necessity for small scale model. They design such larger wind tunnels so that you put full scale car in test sections. Another very interesting kind of wind tunnel, it's an environmental wind tunnel. In this class of wind tunnel, you can simulate not only flow speed, you also control flow of humidity, flow of temperature, you add additional radiation like a sun or high intensity lamp. Also, you can simulate in this wind tunnel rain, freezing rain, and this help to understand how you design work with environment. This kind of wind tunnel also used not only in automotive, in car design, but in aircraft design too. It's very important to aircraft design for your aircraft fly in freezing condition in ice, with ice at wind or fuselage. But this book don't talk about environmental wind tunnel in aircraft application, only in automotive. Next one very important kind of wind tunnel, it's an aeroacoustic wind tunnel, when you need to understand how much noise produce your aircraft. You need a closed test sections with an anechoic chamber. Anechoic means there is no sound reflection from wall of test chamber. In this picture, we see a lot of prism that damping sound, and you have a lot of high sensibility microphones, and you recording your noise from aircraft in each position. In environmental noise, maybe noise below aircraft, above aircraft, noise inside aircraft. Maybe you need to simulation of jet engine to analyze the engine noise. Also, main source of noise from aircraft is landing gears, chassis, and flaps. Edges of flaps, slots, they produce a lot of turbulence flow, and turbulence mean noise. We have no acoustic wind tunnel in Ukraine, but in Antonov wind tunnel, sometimes they do experiments with acoustics. They put a lot of microphones and record sounds from aircraft. But wind tunnel also is a source of sound. There are a noise from fan, noise from engine, noise from turbulence flow at corner. So when you design aeroacoustic wind tunnel, you should to reduce level of this noise, and they have a very thick walls. They talk about this in these books. They have insulation, they have isolation of entire tunnel from ground, several feet of crushed rock, very thick walls from concrete, noise suppressions. So very special kind of wind tunnel. Another kind of wind tunnel is a water tunnels. When you need to visualize your flow in wind tunnel. In air, you can use smoke, but if you have a closed circuit wind tunnel and you put smoke in your model, in your test sections, after 5 minutes, all circuit of your wind tunnel will be covered with fog and you see nothing. But in water, we have dye streaks. We have paint, very small streams of paint, and this better for visualization of flow pattern around model. But in water tunnel, we have a very small size of test section because viscosity of water not so small as in air, and same Reynolds number we achieve with very small size, like for example 40 inches. 40 inches like a less than 1 meters. I seen water tunnel in Ukraine and test sections like 20 centimeters, very small test sections. Also, wind tunnel use it not only in aircraft and automotive, also they use it in sports for skier, for bicycler, and there are a lot of experiments for find better position for skier or bicycler, to find better equipments like a clothing or helmet form. And sport industry put a very big money in wind tunnel experiments. Not only Formula One racing car, but also sky, also bicycle, and as bobsleigh and different kind of sport conduct wind tunnel experiments. Also, there are necessity to building or bridge or larger scale civil engineering structure like a stadium, and they all tested in wind tunnel. This is all about low speed wind tunnel, but we must to talk about high speed wind tunnel also for supersonic speed. So these books show us nothing about high speed. It's titled low speed wind tunnel, and we have some sketch of high speed wind tunnel in this books, and I think it will be second part of our lecture. Now we need to small pause, maybe 10 minutes, maybe 15 minutes, and after pause we start second part of our lecture.